Okay, so today we're going to talk about rate of change. We have been talking about rate of change. We've been talking about slope for a long time. And as I said before, uh, when we were dealing just like not in the word problem context, when we're just dealing with lines and coordinates, we would use the term slope. We'll see that more often. But when we're dealing with word problems and things like that, you'll hear the word rate of change or sometimes just rate. Sometimes just rate. Okay. And here they give a definition. It's really how one quantity changes in relation to another quantity. Okay. If you want to think of it, this is exactly the same thing as your y2 y minus y1 over x2 minus x1. Okay. Or another way to think of it, going back to what x and y is, typically x is your independent variable, and your y would be your dependent variable. Okay. When you, who does experiments, manipulate the independent variable, the dependent variable also change. Okay. So that's kind of another thing to look at the rate of change in this definition. Okay. Now we do have this example here. You have a certain amount of money in your bank account. What pattern do you see in the data? What do you think this indicates a linear or non-linear relationship? Now you have two ways to do this part. Okay, you have two ways to figure this part out. One way would actually be graphing. Okay, one easy way that we have learned so far is by graphing. So in this case, if we're doing a graph, I'm just going to use this as my axis and this here as my axis. And I'm just going to quickly count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I have 18 little ticks. Now, this will not be my maximum value because I'm going to be expected to go above 350. So in this case, I can do what is it? 50, 100, 150, 200, 250, 300. So that would actually be relatively good. So let's just say for every small tick, it will be 25. So this will be 50, 100, 150, 200, 250, 300, 350, and then 400 and 450. Okay. Oh, wait, that's the amount. So I should go this one here. I should go the other side. So my apologies. Yeah. Thank you. I was thinking about this. So 100, 150, 200, 250, 300. So another thing too, if you make those kind of mistakes, that's normal. Just recognize it. Quick. Number of months. So 18 little ticks. Again, we're going to probably go beyond number 8. So in this case, I'll just do 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll go 9. Okay. Now, at this point, I'm going to plot the points. This is 1, 2 is 100. This is 150. Now they skip 4, but they go to 5. So 5 is 250. 7 is, let me skip 6. 7 is 350. Okay. So in this situation here, I'm just going to, now this happens very nicely that it will be a very connecting to straight line. Okay. Now, but without us connecting the line right now, what kind of relationship is this? This will be a linear relationship. The line best fit should be a straight line. So you can do it by either by graphing. Okay. So you can do this either by graphing, linear, and you can figure this out by graphing. Okay, that's one method. Now, another method that I want to teach you today is by looking at the table of values. Okay, by looking at the table of values. Because when you look at the table of values, the months, every month, okay, every time it goes up by one, okay, when it goes up by one, first month to second month, when it goes up by 1 month, this goes up by $50. Okay. When it goes from the second month to the third month, again, this goes up by $50. Okay. Now you notice here, third month to fifth month, this is going up by 2 months. Okay. This is going up by two. But when you go, even if you're going up 2 months, 150 to 200, it goes 100. Okay. So in 2 months, it goes up by 100. So which means it is still if you increase it by 1 month, it would be still go up by 50, right? If you go up by 2 months, it's 100. Well, it's the same thing as going up 1 month and $50. Okay. So if you look at the table of value of how it goes up, this is consistent. Okay. It is consistent. It is always the same rate that it goes up. It is the same rate that goes up. Every 1 month, it goes up by $50. Okay. So you can tell based on this, since rate of increase is consistent or constant, let's use a mathematical term, constant, it doesn't change. Okay. $50 per month. Okay. It will be a linear relationship. Okay. Let me just zoom out a little bit. Is linear. Okay. So you can, so aside from graphing all the data points and then look at how the line best fit might go, you can also look at the table values, how it increases, and to see if the rate of increase are the same. If it is constant, then it is a linear relationship. Okay. By rate of increase on table of values. Okay. Questions? Okay. Now, the second question here, determine the rate of change from a table by calculating the difference. So actually, we did this part just now. Every time it goes up by 1 month, we realize that it goes up by 50. It increased by 50. When it goes up by 2 months, it increased by 100. So that's the same thing. It goes up $50 a month. Okay. Plus $50 per month. Okay. Any questions so far? So here, C, plot the data and draw the trend line. So we plot the data points already. Now I'm just going to draw the trend line. Now, if you may recall, typically when we plot a graph, we do need to label our axes and titles. So in this case, this should be months. This should be amount. A little bit amount, $sign. And this here would be the title. I would probably have months versus amounts of money in my bank. Whoops, my bank account. Okay. Remember my template in terms of title, X versus Y, and then the context. What is this graph about? Okay. Some textbooks say Y versus X. Some books say X versus Y. It doesn't matter. Okay. Now, the last but not least, confirm the rate of change from the graph. So again, this means you can calculate the slope. Okay. So you have two ways to calculate the slope. You can, of course, do a rise versus run. So if we do that, let's just say we go from the lowest point to the furthest point. So it goes all the way here. I have a run of 1, 2, 3, 4. What is it? 1, 2, 3, 4, 5, 6. I have a run of 6. And then I have a rise of, what is it? 300. Okay, 300. So rise over run, you get 300 divided by 6. So that will be 50. So you can do it this way. You could also just take two of these data points, and we can use these two data points and just use our formula that we just learned. So in this case, this point here would be 7 and 350. 350 here, 7 months. This data point here would be 1 and 50. Okay. And then we do, let's just say this is my point 2. This is my point 1. So x2, y2, x1, y1. Okay. I'm just trying to avoid having negatives, so I use the bigger numbers. So down here, y2 minus y1 over x2 minus x1. Okay. So you have 350 minus 50. And then you have 7 minus 1. So in this case, you have 300 on top. You have 6 underneath. So you have 50. Okay. So same way as how you find this, whether you do rise over run on the graph or using the formula. Okay. One of the things I do want to warn you guys about, and this is a very common mistake, when you are doing rise over run, or if you're just picking coordinates to do the formula, always pick from the line of best fit. Always pick from the line of best fit. This is a example where, like, oh yes, all the points are supposed to connect to the same line, so it's going to be fine. But as you might know, sometimes your correlation, not all your data points are going to line up to the same line. So in this case, you still only use your line of best fit, because your line of best fit is your trend of the entire data set. Okay, so make sure always. Okay, I will just write down here. Always use the line of best fit line of best fit, to find rate of change. Okay, this is very, very, very important. Actually, on your quiz, some people I might put LOBF. That's what I meant. Line of best fit. Okay. Any questions? Okay, if you're still copying, don't worry. This will be online. Okay, and you can kind of pause at the screen and then copy if you're missed anything. Now, this is a slightly different data set. So you have here on this graph, you have average speed of traffic versus number of police car on the highway. And as it seems, so x-axis, you have number of police car on the highway, and then basically people's average driving speed. Okay. Now here they say draw a line of best fit through the following data. This, looking to me, this will still work well as a linear line of best fit. So as I said before, you're trying to draw a line of best fit closest to all your points. Okay, some points you'll be going through it, and some points you'll be under, and some points will be over. Okay, I was actually talking with Miss Beckford, who is a specialist in terms of from the school board, talking about for teaching math, and she was saying that in grade 12 data management, she used to teach a formula to like how to tell is this a good line best fit or not. So, but that's a grade 12 thing. Essentially, you're measuring like, oh, the distance of your line that best fit to each data point. Okay, that's the concept of it, but you will learn it if you choose to take grade 12 data management. Anyways, this is my line of best fit. Okay. Determine the line of rate of change from my trend line after determining two exact points on my line. So as I said before, it's the very same thing. You pick your rate of change from your line of best fit. So I'm just going to look here. Again, typically when you have a line, when you draw a line, but they don't tell you which 2 points to change, you would try to pick a point that's directly on the grid of intersection. So I would say this is a good point. And another thing that you want to try is pick another point that's on the grid, that's on the line that's on the grid, but far away. Okay. The reason why is this, because your line of best fit, sometimes you're just a little bit tiny different. And so in this case, if you pick 2 points that are very close, it might not show up that well. But if it is point that is far away, then it will show up. The slope change will be a lot more serious. So always trying to pick another point that's further away that is also on a grid. So right now, I would say this is a good point. Either this point or this point is a good point. I'll just pick this one. This is slightly further away. Okay. So in this situation, I have here, this is, what is this? 1, 2, 3, 4. So every 4 ticks goes up to 1. So 1 divided by 4 means 0.25 or quarter. So here, the x coordinate here will be 0.25. And up here, now let's see. You go up 1, 2, 3, 4, 5, 6. This is interesting. So to go from here to here, you have 6 ticks. And from 84 to 92, that's 8. So basically every one tick would be what? 4 over 3, which is 1.33. Repeat it. So in this case here, this is nicely 112, which is fine. But down here, this is directly right on 8. And is it right on the 92? It is. So thankfully, we don't need to do that other number. You don't need to have decimals so much. Okay? So now you have 2 points, 2 data points. Considering how big or small or weird the numbers are, we probably just want to use the formula, because doing rise over run, it's gonna I foresee a lot more chance of making a mistake. So I'm gonna use the formula. Let's just say this is my point 2. So this is my x2, y2. This is my point 1. So x1, y1. Okay. And then the formula again. Now, when you're doing your homework, I strongly suggest you write out the formula, partly showing which formula you use. It's very important in science and math. Also, another thing, the more you write it out, the chances of you remembering the formula would be higher. Okay. So x2 is 90, y2 is 92, y1 is 112 over x2 is 8 minus x1 is 0.25. So in this case here, 92. Okay. 92 minus 112, that gives me minus 20. And then you have 8 minus 0.25, that should give me 7.75. Okay, 7.75. Now, what we can do what we just learned in terms of how do you get rid reducing the fraction yet just keep it in reducing the fraction yet getting rid of the decimal. Let's just say we multiply both top and bottom by 100. Okay, because we need to move this decimal place by 2, so we need to multiply by 100. It has 2 zeros. Okay, so when we do that, you can have minus 2000 and you have 775. Okay, 775. So you can reduce it. I foresee using 25s and then multiples of 5s. But again, you could always, if your calculator have this fraction here, button here, you can always do so 2 and 18 over 31, or now this is minus, so minus 80 over 31, okay, minus 30 over 8, minus 81 over 80 over 31, yep. Questions? Okay. I don't think the calculator would be able to convert this fraction or reduce this fraction if you enter 7.75, but I just taught you in a way how do you get rid of that decimal when you're in the fraction situation. Okay. Now 80 over 31, that's also the same thing as minus 2.58 roughly. Because what happened is this: in math, we prefer this answer fraction, improper fraction, and lowest reduced form. But in real life conversation and practical situation, a lot of times we deal with decimals. So what does this rate of change mean? Okay. Now, notice two things. This rate of change is a negative rate of change, which means when the number of police cars on the highway increases, people drive slower. Okay? People drive slower. And in fact, with this rate of change, we can say every one police car shows up, every one police car here, we basically, the average speed will go down by 2.58 kilometers. Okay? Every police car increases, your average speed goes down by 2.58. So we're going to write down here for every how I reword this, for every additional police car. Okay, so basically you go up by one, average speed of traffic goes down by 2.58 kilometers per hour. Okay. Yes.
Is this one of the numbers a little bit different from hers? Because I didn't get the same number as you.
Sorry, say again.
The number, is it finding for number is different, or it's close, but it's not the same exact number as that?
Oh, now this is a part where, in a situation where I want you guys to graph your line of best fit and then calculate the slope, typically it really depends on your line of best fit. Even when I do the line of best fit, let's just say if I grab another extra copy of this and graph a line of best fit, my numbers might be slightly different. Okay, so this is on a test and exam. I will be either get a number of teachers to do a line of best fit and do analysis, or I might use the computer to graph the line of best fit and then have a range where like it's okay to be different. Okay, but if it's too far off from that range, then you'll lose mark. Let me talk with another teacher first. Okay. Like if your graph, I would say if your graph is all the way here, like all the way down here, that will have problems. Okay. But right now, if you're kind of somewhat consistent to be close to the middle of all your data, then it should be okay. Okay. Questions? Okay. So for homework, this handout, do the almost and ready or ready and more. Okay. Do keep in mind that your quiz next Monday would include the word problem, the rate of change word problems. Okay. So let me know if you have any questions. I'm just going to stop the recording now.